Problem 7 has the potential here to be much more difficult than the other problems in this section, except for the fact that they kind of threw us a lifeline here that makes it a little bit nicer. Same basic premise. We're trying to find a rate of change, or a derivative, of the volume of a cylinder with respect to its radius. Now, here's where this problem could be interesting. The formula for volume of a cylinder, which I'm sure you all remember from geometry, is this. It's the area of its base, which is pi r squared, multiplied by its height. And what could make this a difficult problem here is the fact that there are two different variables over here on the right-hand side. So trying to take the derivative of this volume formula looks like it would require a method we haven't learned yet called implicit differentiation. It doesn't come for us this year, guys, until section 3.8. However, here's the little lifeline they threw us. They said that in this particular cylinder, its height is going to be equal to its radius, and that means that I can replace one of these two variables with the other one. Now, they're telling me to do all of this with respect to r. So what I'm going to do now is rewrite my volume function here as pi. I want to keep the r in it, so that's pi r squared, and the h can now be replaced by r because they told us right there those are equal. And what's interesting here, guys, this volume function is now expressed completely in terms of the variable r, so I'm going to call this function v of r. It tells me the volume of a cylinder as a function solely of its radius. And I think I should probably go ahead and simplify that just a little bit and make that pi r cubed. Otherwise, I'd have to use the product rule the way that it was written before, so no, we're going to go with this one right here. So let's find its derivative, v prime of r. Here we go. I just need to remind everybody, pi is not a variable, it's a constant. So treat it like it was a 5, and then here you go. We'd bring the 3 out in front and multiply it by the pi to get a new coefficient of 3 pi. The variable base stays the same, and the exponent drops by 1 from 3 to 2. And there's your derivative, guys. That's v prime of r. And so now, if I'm looking at this problem correctly, this looks a little different than the other ones here. I don't believe, unless I forgot to write it down, they gave us a specific value of r to put in there, did they? Volume of a cylinder equal to its radius. Nope, that's it, guys. So that's the formula here. They didn't give us a specific value of r to put in there. So v prime of r then would be equal to 3 pi times its radius squared.